Chapter 7.2 is Similar Polygons, and our essential question is, how can you use ratios and proportions to decide whether two polygons are similar? Similar figures have the same shape but not necessarily the same size. You can abbreviate the words is similar to with this symbol. And here is our key concept diagram for similar polygons. It says two polygons are similar polygons if corresponding angles are congruent and if the lengths of their corresponding sides are proportional. So the angles must be congruent and the side lengths must be proportional. When three or more ratios are equal, you can write an extended proportion. A scale factor is the ratio of corresponding linear measurements of two similar figures. Basically, what that tells us is it's the ratio between the two figures. So over on the right for these triangles here, it says that for BC and YZ, we're going to look at side lengths BC and YZ, and we can see that it's 20 to 8. And so they simplified it here as a ratio of 20 to 8 or 5 to 2. So that would be our scale factor. Problem 1, understanding similarity. In the triangles at the right, triangle MNP is similar to triangle SRT. Part A, what are the pairs of congruent angles? So I'm going to write down that angle M is congruent to angle S. Angle N is congruent to angle R. And angle P is congruent to angle T. Part B says, what is the extended proportion for the ratios of corresponding sides? And I'm actually going to make a copy of this picture. And what I did is I actually flipped it and turned it so that it would match up with the other triangle, so that the two are lined up. That will make it a lot easier to write the proportion for the sides. So let's go ahead and do that. We have side MN to side SR, NP to RT, and MP to ST. For problem 1, got it, we have DEFG and then shape HJKL. What are the pairs of congruent angles? And again, the first thing we should notice is that the angles should line up. So our congruent angles are going to be angle D and angle H, E and J, F and K, and G and angle L. Problem 2 is determining similarity, and it says, are the polygons similar? If they are, write a similarity statement and give the scale factor. Well, the first thing we should do is identify pairs of congruent angles. And so taking a look, JKLM and TUVW, J and T, it tells us are similar, and they are congruent because of the two little marks. We've got K and U are both 90 degrees. L and V are both similar because it gives us the 3 marks. And then M and W are also congruent. The next thing we need to look at is determining if the sides are corresponding. So we're going to look at the ratios. So first let's look at JK, side JK right here, and TU. So JK is 12 and TU is 6. So let's simplify that, and that becomes 2 to 1. Next, let's look at KL, and that corresponds to UV. KL is 24, UV is 16. When I simplify that, I get 3 to 2, And I'm going to stop right there because I can see that these are not similar because they don't have the same scale factor. I could go on and find the scale factor for the other sides, but I know that since it's not the same, that these aren't similar figures. So going to part B, I'm going to look at triangle ABC and triangle EFD. And the first thing we should do is to see if there are pairs of congruent angles. And so first we have angle A, and that is congruent to angle D. We have angle B, and that is congruent to angle E. And then angle C is congruent to angle F. So I do have pairs of congruent angles. Next we're going to look at the ratios of the corresponding sides. So first let's take a look at side AB, and that would correspond to side DE. AB is 12, DE would be 15, and let's simplify that to be 4 over 5. Now let's take a look at another pair of sides. Let's take BC, and that would correspond to EF. BC is 16, EF is 20, and that simplifies to 4 to 5. So far so good. Let's take a look at the third pair. I have AC and DF. AC is 8 and DF is 10, and again simplified 4 to 5. So yes, the two triangles are similar and the scale factor is 4 to 5. Either written as a fraction or as 4 to 5. The problem 2 got it. It says, are the polygons similar? If they are, write a similarity statement and give the scale factor. I want you to do this one on your own, and in order to receive credit, I need you to actually answer this and show all of your work. Problem 3 is using similar polygons. So ABCD is similar to EFGD. We're going to look for the value of x. So first, since I know they're similar, that I know the sides must be proportional, so let's go ahead and set this up. I'm going to set up FG to BC. And I know that must be similar to ED to AD. And really what I've done here is I've taken the smaller side to the larger side, and then smaller side to the larger side. Let's go ahead and substitute in the numbers. So FG is X, BC is 7.5, ED is 6, and AD is 9. Let's go ahead and solve this by cross multiplying. So I have 9x equals 45 and x equals 5. For the problem 3 got it, you have ABCD is similar to EFGD. You're looking for the value of y. I'm actually going to give you the answer. The answer is 10 to 3, but in order to get credit for your notes, you need to show all of your work. Problem 4 is using similarity. So your class is making a rectangular poster for a rally. The poster's design is 6 inches high by 10 inches wide. So we've got 6 inches high by 10 inches wide. The space allowed for the poster is 4 feet high by 8 feet wide. So we have 4 feet by 8 feet. What are the dimensions of the largest poster that will fit in the space? So right now we have 2 different units, so let's go ahead and get everything into inches. So the 4 feet will be 48 inches, and the 8 feet will become 96 inches. So now comparing the sides, I can see that the 6 inches needs to fit here, and the most that the 6 inches can go into 48 is going to be 8 times. And looking at the width, I've got 10 inches and I've got 96 inches. So I know that this can be at most 9.6 times. So of course we have to go with the smallest number, and that is going to be the 8. Now I just need to know my width, because I know if we go the maximum it will be 48 inches tall. So from the small poster to the big poster, it's going to be 6 to 48. And from the small width to the larger width, it's going to be 10 inches to an unknown. So let's figure that out by cross multiplying. I have 6x equals 480. And so x will be 80. So I know that my dimensions of my poster are going to be 48 inches by 80. The problem 4, got it? You're going to do the same problem using different dimensions. Go ahead and show all of your work in order to receive credit. The last thing we're going to talk about is a scale drawing, and it says in a scale drawing, all lengths are proportional to their corresponding actual lengths. The scale is a ratio that compares each length in the scale drawing to the actual length. Problem 5 is using a scale drawing. It says the diagram shows a scale drawing of the Golden Gate Bridge in San Francisco. The distance between the two towers is the main span. What is the actual length of the main span of the bridge? So what we're going to do is take a look and figure out. It says here the length of the main span is 6.4 centimeters. We want to figure out how far that actually is. I have 1 centimeter is to 200 meters. And I know that my scale here between the two towers is 6.4 centimeters. I want to make sure that since I have centimeters as my top number, I want that to also correspond over here. So I'm going to do 6.4 centimeters, and I'm going to figure out how many meters that is. So that's x meters. And to solve this then, we're just going to cross multiply. So it's 1,280, and I know that my scale must be in meters because that's what I'm looking for here in this variable.